ammonia refrigeration systems in like 3 minutes. Basically, somewhere in your fish plant, in your food plant, in your cold storage facility, in your ice rink, there's going to be a big giant tank full of liquid ammonia. This is ammonia pressed into a liquid. Think of it like a propane cylinder, right? If you open a propane cylinder, propane would go into the air. If you cut a hole in this, ammonia would go into the air. There'd be no liquid left. This ammonia gets shuttled through pipes. Ammonia is going this way. The little steel pipe, it's going to have some kind of insulation on it. It's going to look like a big silver duct, but really inside there's a little metal pipe. This is going to go to an evaporator unit. This is a sealed unit. None of this ammonia ever goes into the atmosphere. If it goes into the atmosphere, we're being called because it's a problem. But basically, as the liquid comes out here, it hits this larger space, it turns into a gas. It expands. This is now full of ammonia gas. And just like when you have a pot on the stove, a pot of water that you want to turn from liquid water into water vapor, you need to add heat to it. You need to add heat to this ammonia. Now, you don't add heat with a burner or something. Ammonia will suck the heat out of the air because it's got such a low boiling point. So it's making the environment around it very, very cold. It's making this cold, and it's taking that heat that used to be here, turning it, bringing it here, and letting the liquid turn into a vapor. At this point, the vapor goes back, goes through a compressor, which squishes the vapor down into a liquid, and that liquid goes back into the tank. Obviously, this is super crazy simplified, but it's just to have the general idea. Somewhere in the plant, there's going to be this evaporator that's going to be very, very, very cold, and be blowing air past it. It's not mixing it with the ammonia vapor or anything. It's just if you blow air past a very, very, very cold unit, that air will get cold. That's how they cool everything down in the plant. Some plants, they've got another addition. As this gets very cold, it frosts up. You get ice forming on this. So they've got another line here that goes through a whole bunch of machinery, but it's going to be a hot gas line. They're going to take some ammonia, they're going to heat it up just under 100 degrees Celsius, and they're going to send hot gas down here intermittently. Every couple of hours, every couple of days, they send super hot gas into here. They shut down this, they shut this down, and they fill this up with hot gas, and that melts the ice. So often you can have 3 lines. You can have 2 lines going from the liquid ammonia. This goes to a hot gas unit, production unit, where basically they take it, they heat it up, and they send it out. This is just ammonia liquid coming out, so 2 lines going out. Here, when it's operating normally, this is open. As the liquid turns into a gas, it makes everything super cold because it drags the heat out of the room, and then it sends the vapor back here where it gets compressed and put back into the tank. That is a vast simplification, but it's a general principle of air conditioning. It's a general principle of how ice rinks chill the brine that runs underneath the ice. It's a general explanation of how your fridge works. Ammonia is not the only thing. It could be other refrigerants as well, but because ammonia is so cheap and because ammonia works so well, most of the huge facilities that are out there, the ones that have got 10,000 pounds of ammonia, 30,000 pounds, 100,000 pounds of ammonia, they're using ammonia. They're not using Freon, they're not using propane, they're not using anything else.